Hey guys, Joe at Small Home Offer Prepping. Welcome to our channel. So today I'm going to jump right into this today because we've got a lot to cover. I'm going to be talking about grounding and bonding and explain what is the difference between grounding and bonding. This is a bonded panel over here, and I'll get into that in a second over covering all that here. This is a secondary grounding system here, and again I'll explain that. I'm going to be covering what's the difference between bonding and grounding, and we're going to talk about a couple different grounding systems because I do have them both here in my house. We're going to talk about a electrode grounding system with 2 ground rods that are per code 6 feet apart. The last company that I managed, it was our requirement that our technicians went 8 feet apart, and I'll get why into a second, but code is 6 feet apart, but again we required our technicians to do 8 feet. And then we're going to talk about a UFER grounding system here because I have both. I have a UFER. I'm going to get into what a UFER is and what's the difference between a ground rods and a UFER, and pretty well all that there. So like I said, I do have both of them here at my house, so I'm going to explain to you guys exactly what that is. So first we're going to jump into what is a grounding system. Okay, not bonding, what is a grounding system? And a grounding system is basically going to take overcurrent, which will come from lightning strikes, power surges, power spikes, a lot of different areas, and it will safely divert it through into a grounding system. Okay, so basically what a grounding system is doing is, again, taking an overcurrent and it is diverting it down into the ground, into the grounding system, whereas bonding is completely different. Bonding, you're bonding metal devices together, metal boxes, metal, even plumbing. If you have an older house that has copper plumbing in it, that has to be bonded. Okay, so basically what that means is you're connecting that to a ground. And well, I'll give you a really good example because it happened not that long ago. It was an older house and a customer had just bought it. I was the manager for the last company I was working for, and my technician could not figure out what the problem was, so I had to go get involved with this. But basically the house was about 20 years old and the customer had just bought it. Okay, so what happened was 20 years ago somebody had ran a screw through a wire, okay, and it turned out to be in the kitchen. They ran a screw through a wire and into a copper plumbing pipe, okay, and it sealed. There was no water leaks. If it was maybe a drip that was so small nobody ever noticed it. But her complaint was every time she went to take a shower or wash her hands, she was getting shocked. It's kind of a strange thing, you know, you go to jump in the shower and you're getting shocked, or you go to wash your hands or do dishes and all of a sudden you're getting shocked by electric. Well, that's what happened, okay? Somebody had ran a screw through a wire and into a copper pipe, all right? So now, knowing that water is a conductor, the water became energized with electricity. So that is why we have to bond, okay? We ended up figuring out, I went out there and ended up figuring out what had happened, and I had dealt with this before, so I kind of suspected it over the years. It's not the first time I came across it, so, but that's why we have to bond copper plumbing, okay? She's quite lucky she didn't get shocked, actually worse. So what bonding basically does, and you see over here in this panel, this is bonded. There's a lug that's screwed into the panel itself, and then there's a ground wire that connects to it, okay? And we're looking at that right over here. So you see here we have wires coming out of breakers, okay? So what's going to happen, anything metal, it does not matter what it is, okay? Anything metal that has electric in it, panel, raceways, pretty well name it. If you're using metal boxes, you know, for receptacles compared to like plastic boxes, those all have to be bonded. So you're going to basically just have a lug like this that goes into the panel itself. There's different ways to bond different things, but in the panel case like this here, okay, you basically have the screw that screws into the panel, then the wire connects to that. So now what happens if this panel were not bonded, and one of these wires here comes loose and it hits the side of the panel over here, hits anywhere in the panel, now this panel's become energized. So anybody walking over to open the panel or touch the panel, it's a potential shock hazard. They could become electrocuted. So that's why we have to bond metal things. What would end up happening, if it is bonded to the ground and a wire comes off a breaker or a wire energizes it somewhere, you know, it can come from many different ways whatsoever. You know, a power line wire can come apart in a meter can and, you know, basically energize a meter can. So there's a lot of, and it's basically any time that electric hits a metal device, a metal box, anything like that. So what it would do is it would trip the breaker, okay? So I kind of jumped ahead a little bit here. I want to talk about grounding more before I talked about bonding, but we kind of jumped into bonding over here as well. And I'm going to show you guys some different examples of bonding and grounding here. So I'm going to start in a meter can, okay? So let me go jump real quick over to my other panel so I can show you guys a couple things. Alright, so this is the meter can on my pedestal. So this is the first place power is coming in. You guys seen this on the last video that I just did here when I explained everything. This pipe comes up from the power company's transformer, comes into the meter can. and that connects from there basically. So the grounding I'll show you. I have an open meter can, so I'll show you, but I wanted to jump into the couple things here real quick here. So the meter can, the ground is bonded together with the neutral inside of this meter can, and I will show you that in a second here. So like I said, when you get lightning strikes, you get overcurrent, you get any kind of power surges, stuff like that, if you don't have a good grounding system, it is going to back up through the neutral. Which again, I can show you guys an example of that in a second, but I showed you a few videos ago where I had that problem, where I had a bad surge protector, I didn't have a good grounding system on my temporary service, and I had a lot of electric fry because of that. So basically this is what you have over here, okay? You have the ground coming out, which comes out of this pipe right over here, connects to a grounding bridge right over there. Again, a grounding bridge is code, because years ago what you would have, if you had a utilities company come out and they wanted to connect the phone or connect cable, a lot of times back then guys would just cut the ground wire, then wire things back together, and you cannot do this, okay? Ground wire has to run continuously per code. And if you're an apprentice, the codes that we're going to talk about today, you'll find in section 250 of NEC, National Electric Code Book. It's in section 250. So like I said, this ground wire has to be continuous. This is a 200 amp service, so this is a number 4 wire that we used here, and there is a chart. If you look, I believe off the top of my head, let me think, I think it's section 250.66. Yeah, I'm pretty sure that's what it is. 250.66 will give you a chart with ampacity and what size ground that you need to run. So the ground wire runs continuous. So it's one wire, it runs continuous. I haven't opened up the grounding bridge here, but all we did inside the grounding bridge, all I did was strip the insulation off, and then I screwed, put the screw down on top of that. So this is all bonded and grounded over here. Then the wire comes down here into the ground, okay? And from there, I don't really remember where it is. This is all grown back over here, but there's 2 ground rods buried. And there's somewhere, well, it's not here. I'm not going to start digging up my ground over here, but it's somewhere there's a number 4 wire that runs along underneath here, and then it connects to 2 ground rods that are 8 feet apart, okay, heading over in that direction there. So that is the first of your grounding system. So the ground, I'll show you in a meter can again in a second, but the ground and the neutral are actually connected into the same place. So your first means of disconnect, which is this panel right over here, okay, you'll notice when I come over here, I didn't even bother using that over here. This is my bonding screw right over there. If you see that green screw right there, if I wanted my neutrals and grounds to be separated, I would unscrew that. That screw goes through this grounding bridge over here. It's a neutral bridge, it goes, a neutral bar, whatever. Basically goes through there, and it bonds the panel itself. So it wasn't much of a reason for me to use this. If I wanted to separate my grounds and neutrals, and still the panel would have to be bonded, then I would have used this for my grounds over here. You see it's screwed directly into the panel. But in this case here, because my neutrals and my grounds have to be bonded together at your first means of disconnect, I just put everything right here on the one bar, and then I just screw that screw down in there, and that bonds the whole panel there. So that is your first means of disconnect, okay? And reason being is your surges from lightning strikes, from a lot of different places they come from, are going to basically back up through the neutral. And I'll show you guys here real quick. I explained it before, but let me go grab that meter can I had burned up, and I'll explain it to you guys here. Alright, so if you guys remember from a few videos back, I showed you this already a while. I mean, 3, 4, 5 videos back. I really can't remember what it was, but you can see down over here how bad this lug melted right over here. This is all apart now, so it's a little hard to see actually the damage that was done, but this is what happened, okay? When I was building the house, this is the first temporary panel that I had, the meter can over here, and this was the panel down over here. What basically ended up happening was I didn't have a good grounding system in it. It's only a 60 amp service. Code said that you only needed 1 grounding rod at the time, and it was number 6 wire I used. It was only 60 amps, so like I said, the wire size does depend on the amperage, but I did use a number 6 at the time. So I put a surge protector on it, and I put a very, very chintzy, cheap surge protector that I'd spent years telling people that you don't want that in your panel. It's garbage. But I figured it was better than nothing. So anyways, one day we got hit by a big surge. The surge backed up through the neutral because I did not have a good grounding system in here. So it backed up through the neutral, and everything on the neutral side of all this, it completely fried, going all the way to the RV receptacle, fried, and everything was on the neutral end. So that's basically what it does. These are bonded together at the first point of entry where the power company's wires are coming in, because that's where it's going to actually take the surge, and it's going to divert it from the neutral down into ground, okay, your excessive power. So I got a better meter can here, which we'll go take a look at, and I'll explain some different things to you. I got the one that I actually put in after I replaced this one here, which I don't need anymore, but let's go take a look at that one. Alright, so yeah, this is the meter can that I told you guys. I actually replaced the other one with when that one got burned up, and that neutral looks burned. It's not. That's just the wire grease, we call it. that's kind of backed up over there, made it look black. But so now if you look over here where the neutral's coming in, you can see that little screw right on the right there. I'm going to zoom in right there. That is where your ground connects to. So you see that your ground and your neutral at the meter can, which is the first point of entry from the power company, at the meter can is basically bonded together, and then when you leave the panel, it becomes bonded together. So, question being, why would we bond it there and we don't bond them, we separate neutrals after we leave the first means of disconnect? We're going to separate the grounds and the neutrals. Very, very simple, okay? At that point where the first means of disconnect is, once you leave that, your neutrals, what you would do is you create a redundant neutral is what it's called. Your ground would want to become the neutral because it's the least path of resistance. So if I were to bond all these panels over here instead of the neutral going back all the way to the main panel, the first means of disconnect, it would want to go through the ground over here, okay, because that's going to be the least path of resistance. However, like I said, once we leave that first means of disconnect, then again, everything has to be separated. My grounds and neutrals are separate over here, so the current is going to flow through the hots in this panel over here, and the neutral all the way back to my main panel, the first means of disconnect, and the grounds do not interfere with that whatsoever, okay? That is why these have to be separated after you leave the panel, because you will create a redundant neutral. The current is going to try to go through the ground, not the neutral, all the way back to the main panel, and it's going to cause you some issues. So, like I said, that is bonding. You see here we bonded this. This box, if you see me install this is a metal box over here in the back, plastic cover in the front, but the box is metal in the back. We had a bonding screw. And I showed you guys how I like to bond that, and same thing with this over here, okay, the generator inlet, that also is bonded. There's a green screw that the ground wire connects to, okay, so like I said, bonding is basically connecting metal boxes, metal devices, metal equipment, I guess I should say, to your grounding system. That is not grounding it, it is bonding it to the grounding system, okay, so that is a difference in grounding and bonding. Grounding is you're creating a path of least resistance for overcurrent, from lightning strikes, power surges, to go down into the ground itself, okay? Bonding, you're basically bonding that equipment to the ground itself. So that is really a difference in grounding and bonding. And like I said, now this one over here, you see we have another grounding bridge, and I'll shoot down a little on the top here. I'm not sure how that looks, but you see those little holes there. There's screws. If I take this plate off, there's holes over there, and actually I think I might still have this one loose. Give me a second, guys. I'll take it off. Alright, so that's what it looks like without the cover, and you see, I don't know if you guys can see that or not, you can see the wire coming through, and this screw over here on the end. My wire comes from this panel over here, okay, it's grounded into the panel itself. This is not the first means of disconnect, this is a secondary grounding, and this one is actually connected to my UFER. This is a brand new house, and like I told you guys, the first one was connected to 2 ground rods that are 8 feet apart with number 4 wire. This is connected to my UFER, okay, again with number 4 wire that's grounding this panel here, and you see the surge protector we have over there. I did not show you the surge protector on the other panel, but we also have a surge protector on the other panel as well. So I'm pretty covered from surges. This surge protector here is not a main. This is actually a secondary on the sub panel, which means this is going to more protect my house from internal surges. Internal surges can come from a lot of different places, like electric heaters kicking on and off, air conditioners kicking on and off. They create internal surges in your home, usually not big enough to cause a lot of damage, you know, like a power spike or a lightning strike would. It's not that kind of surge, but what it is it's little surges that hit devices over and over and over, and as time goes by, it'll cause your TVs to go bad, it'll cause other electronics, motors, can shorten the life of your refrigerators, you know, things like that as well. A lot of people, you know, you go out and you buy a TV that don't have a good surge protector, the TV lasts 6 months, a year, and all of a sudden the TV goes bad one day, and they're like, oh my gosh, what a piece of junk, I can't believe I wasted my money on this TV. Well, guess what? It's most likely your fault that that TV went bad. If you don't have a good surge protector on your house, and you don't have a good grounding system, and keep in mind, a surge protector without a good grounding system is actually worse, because when it tries to divert that through the surge protector into the ground, you don't have a grounding system, it's just going to shoot it right into the neutral at that point. And again, that's something I've seen over and over. I had one case, actually, the same company that I managed, but I was a technician in the field at the time. I just started with that company 4 or 5 years ago, whatever it was. So anyways, I got a call one day that the customer had a huge lightning hit, and they had areas of the house that did catch on fire, but it was small fires. They were able to just shoot it out themselves. But when I went out there and looked, what I saw happen was there was a lightning strike, okay? The lightning strike hit the transformer right out in front of their house. Their grounding system was over 15 years old. It was, and if you have a grounding system with zinc ground rods that are over 15 years old, you probably don't have a grounding system, because zinc ground rods will corrode after about that 15 years, and that's what happened. They really had no grounding system, and it was the worst strike I ever seen in my life. They had receptacles literally blow out of the house, out of the walls, and you can see the black from the soot. The 2x4s where the boxes and the nail boxes were nailed into, a lot of them were like black and burnt. They had a shed out behind the house, and when I went out to the shed out behind the house, they had, you know, the joists and things like that had holes drilled where the wires passed through, and the wires exploded at such a fury that it actually cracked these beams. It cracked the roof trusses, you know, it cracked joists, it cracked studs. I mean, it was really, really bad what I saw there. It ended up being an insurance claim, but it was the worst I ever seen, because they did not have a good grounding system, they did not have a surge protector, and the lightning strike just came directly into their house and fried everything with it. It took out. So yeah, like I said, that was the worst that I ever seen as far as, I've seen a lot of damage from lightning and power strikes. I've suffered damage from lightning and power strikes myself, and that house was the worst. But again, like I said, it was the grounding system. If you guys don't have a good grounding system, then it's basically pointless. Don't even put a surge protector in, because you'll cause more damage most likely than not having a good grounding system. So like I said, guys, this is my UFER. Before I jump into the UFER, I want to show you a couple more examples of bonding. Okay, so you guys have seen this many times. This is my solar inverter. And this actually, when you look at it, I have the washers covering it, but it says ground, and it has a little ground symbol over there. But technically, this is bonding. This is being bonded to the grounding system over here. So this is not technically grounded. This would be more technically bonded to the grounding system. If anything shorts out inside of this metal box here and it touches the side of the box, it will trip the circuit that this is on. It will trip the breakers. In this case, it would trip these two fuses down over here to shut down the inverter, so it's safe. Another example you can see here. This one's going to be a little hard to zoom in over here, but if you look back over there, again, you see the ground connecting to a lug that's screwed directly into the metal box. That is both bonding this box and creating a ground to attach over here, which actually, as you see over here, I used a crimp, and I have a lot of different grounds that are attached here. I think I have like at least 3 grounds attached into here. Bonding the box and actually bonding some other things as well. So that's another example of bonding. But as you see here, the metal box itself has a wire screwing into it. If a wire were to come off, keep in mind this is fed by a breaker over here, okay? It's not just coming off of power from anywhere. There's a breaker. So if the wire were to come off, a live wire, and hit the side of this box, it would trip that breaker, making it safe. Okay, so that is bonding. Now if we look at the transfer switch over here, okay, as you see here, this one I haven't even connected yet. I've been using this and sitting here. Right now that one's kind of irrelevant to me, because the grounding for all this is still coming through the cord over there. So if I want to unplug the cord to the generator inlet and all that, then I would have to connect this ground, because I wouldn't be grounded. But now it is grounded. It runs through that main ground over there. Eventually I'll get back around to this. But this here is a plastic box. So as you see, the plastic box does not need to be bonded. It's not a connector. So this is just a grounding point right over here. It's a place to connect your grounds, but it's not bonding anything inside of the box over here as well. Okay. Same thing with this. It's a plastic disconnect, just like the metal one I showed you over here. This one, again, does not need to be bonded. It has the same kind of little bar like that just screws into the plastic. So, guys, that's a couple of examples here I've showed you. Solar falls under the same exact thing. So when you're putting solar panels in, photovoltaic cells are covered under Article 250. You will find them over there. So the grounding is all the same. Let me show you the panels themselves, how those are bonded. Alright, so you see here, guys, these clamps that I use, these little straps. If you've seen the video where I put all this up here, you know I custom made all this here. It goes all the way up. Every one is overlapping. So you see here, there's 2 of them. There's one connected to each panel, then they overlap. That is bonding all these panels, and I tried to bring my meter up here to show you guys, because I tested all this when I did it, to make sure that I had the correct ohms here. It's got to be less than 25 ohms to create the resistance here. So I did check this when I put it all in, all the different panels. You see they're all pretty well the same thing, going all the way over to there. So that bonds all these panels together. I am running a separate ground right now. I have this roof. It's a metal roof. As you guys see, oh, anyways, can't see it. You can see the top over here. It's a metal roof. Okay, so the roof itself I have grounded. bonded to the grounding system. So, and this has a lug that runs directly through the roof, through these panels and all that. So that is, and it does have less than 25 ohms resistance, but it's not something I'm going to leave. I am going to be redoing that and running a separate grounding rod in for this over here. But panels themselves also need to be grounded as well, and that is covered under section 250 of the National Electric Code. So that's another example of bonding. So I've showed you guys a few examples of bonding here. All you're doing is you're bonding metal things to the grounding system itself. That is not a grounding system. It's bonding to the grounding system. So let's go take a look at the UFER. Alright, so this comes down over here. It's a number 4 wire. I'm not going to dig this up. We're going to run along the side of my house over here. And I'm not going to dig this up, but the wire comes along over here and comes right down to about this point over here, I want to say. I'm not going to start digging it up because, like I said, I actually have a lot of pipes running underneath here, and I'd have to get around those pipes. The UFER is actually far lower than those pipes are over here. Those pipes go to this box over here, which is not an electric box. It looks electric, doesn't it? It actually confused the inspector because when he came out for my final inspection, none of this was buried yet, and there's a bunch of pipes that were only sitting about 6 feet underground. They were, well, you can see down over here, there's 3 of them. And that's what, 1.5 inch pipe I think I used, maybe 1 1/4. Yeah, it's 1 1/4, I believe. So anyways, he sees all these pipes over there and he's like, what is that? This is a hub for my security system, my internet. Like I told you guys, I have a 32 camera security system here that has cameras all over the property. I've buried well over 5,000 feet of wire. It's all hardwired. Some of it comes up into this box right over here, and then I pre-wired everything in the house when I wired the house here. So it goes to the digital video recorder, the DVR for my security system here. So this is not electric over here, but all the pipes coming into here are buried along here. So I'm not going to dig this up, but what a UFER is it's basically a concrete encased grounding system, and in my case it's the rebar. Okay, so when my slab was poured, the rebar was connected together. It is 3/4 inch. In 1978, NEC did allow, and I don't know today because I don't deal with it in my area. I'm not familiar with any kind of building construction that lets you use 1/2 inch rebar. My house is 3/4 inch, and I believe most is going to be 3/4, but I'm not 100% sure. But I don't believe 1/2 inch is really used in houses anymore. But NEC did allow UFERs to be connected to 1/2 inch rebar back in 1978. Okay, so what happens is all your rebar is bonded together. Now, what they found, a couple things with a UFER, there's pros, there's cons. Okay, and the pros to it is a concrete encased grounding system. Well, let me back up a second. Let me explain to you guys where the UFER first came from. It was during 1942. World War II, let's just say World War II, I think it's 42, around there. In Arizona, Tucson area, they had a problem with the grounding systems. They had big metal buildings that they were storing bombs and, you know, explosive equipment and stuff like that as well. And they had a problem because the sand is so dry out there, it's all desert-like conditions. The only way that they can get a correct grounding system with less than 25 ohms of resistance would be to use ground rods that were over 100 feet deep, and they'd have to pound a bunch of them in. It didn't work. Okay, so I think his last name was UFER. I think it was Charles. Can't remember off the top of my head, but anyways, he came up with a system with concrete encased using the rebar. Okay, now why does that work better? What they found is the concrete, because the concrete is high in pH, the concrete's going to do 2 things. One, it's a much better conductor than the actual soil the ground is. The other thing, though, is when the concrete is poured, the soil around it, also the pH increases as well. It makes it a better conductor. Okay, so what they found is the grounding system in a UFER is much, much better than electro grounding rods, simply for the fact that you just have a higher area of disbursement for the grounding, and you also have a much better conductor because, again, the cement itself is a much better conductor than the ground is. Okay, so that's why UFER works better, and they're called UFERs. They're really not. Okay, they were named after the guy who designed them, but there's a lot of different designs when it comes to that. It's a concrete encased grounding system is what it actually is. It's a grounding system encased in concrete that's been poured over it. It has to be a minimum of 2 inches, I believe it is, from the outside of the concrete. I'll double check on that here, and if that's incorrect, I'll throw a correction in over there. But if I remember off the top of my head, I believe it was 2 inches. A lot of that does come down to your concrete guy when he's putting this in, though the electrician does have to be involved, and in my case I was completely involved because I'm the contractor on my house. I built my house myself. So anyways, like I said, that is a UFER. Okay, so from there, there's going to be a piece of rebar that sticks out of the slab from the footer, and like I said, in my case, I'm not going to dig this up again, but that piece of rebar, again, came out like right over here in the back. So that's where I used the acorn. I connected over to the UFER itself. All right. Now, UFER is a much, much better grounding system, but what is the downfall to a UFER? There's one downfall to a UFER, okay? And if this was a main grounding system for my house, because keep in mind, this is the secondary, I have a surge protector on the first, so the likelihood that my house is going to get hit by a surge or lightning strike big enough to cause damage to the foundation from the UFER is pretty highly unlikely. But what happens is the current could go through so fast, so much current from a lightning strike or whatever into your UFER, that the moisture in your concrete evaporates. And you can actually see, and I've seen pictures of it, I've never seen it in real life, but I've seen pictures and video of steam actually coming out of the concrete itself, where the moisture is evaporating from the concrete from the amount of current that just went through and heated everything up inside. All right, so that is a downfall to the UFER because it'll dry out your concrete, and concrete can develop cracks, and a lot of times the cracks they develop are so severe that it creates permanent damage to a foundation. Extremely, extremely, extremely rare. Monster size current would have to go through it for that to happen. But if I, like I said, if I actually, this was my first means, my first grounding system here, I probably wouldn't like my UFER as much as I do here, but it's not. Okay, so this is really, at this point, keep in mind any surge protection, anything like that, my grounding system, this is all designed more for internal stuff. Anything coming external would be at the main point, the main one that I showed you guys out there, the pedestal and all that, where the main grounding connects. So that's a couple of different examples, guys. Like I said, there was a lot to cover here. I'm trying to go through this and not leave anybody confused with this, because grounding is something that confuses a lot of people, even technicians. I've asked guys who are supposed to be master electricians what exactly a grounding system does, and why do we need one, and the most they can say is, oh, it diverts over current. That's it. They can't get into a lot of details about it and this and that. They know enough to know that it diverts over current, which it does. It brings it safely to the ground. Again, same thing the surge protector does. Okay, it will take excessive voltage, excessive current, and safely direct it through the grounding system into your main ground. Again, if you don't have a good grounding system, that's not going to help you. So, like I said, guys, that is grounding. Another example, we call bonding a pool. Okay, you have to bond a pool. If you have an above ground pool that's metal, you have to bond that pool as well. And I'm not going to get into that today because I might make a different video on that as well, because that one's a little bit tricky too, because technically you're both creating a grounding system. When you're going to bond a pool, you're both creating a grounding system and bonding that pool to the grounding system at the same time. But you're not using a UFER, you're not using ground rods, you're not using anything except bare wire to do that. So that'll be a different video. I'll get into that. If you guys have any questions, hit me up in the comments here. I'd like to basically be as quick and thorough as I possibly could. So that is the difference between bonding and grounding. Again, grounding, you're creating a path of least resistance for overcurrent to flow down into the ground. Bonding, you're taking metal boxes, anything that's metal that has electricity involved with it running through it, raceways, things like that, and you're actually bonding that to the grounding system. Okay, so you're not actually creating a path of least resistance for overcurrent to be diverted into the ground for. You're actually taking metal boxes, anything that's metal, and you're bonding that box to the grounding system. So if that box became energized with electricity, it's going to trip the breaker, it's going to trip wherever that source is coming from, and kind of go from there. So like I said, guys, hit me up in the comments if you have any questions here, anything like this. I told you that other ground isn't connected right now because I leave this plugged in all the time. This is grounding the entire thing, but if I were to unplug this cord right over here, this black cord, then I would have to connect that ground wire over there because I wouldn't be bonded over there, or grounded, yeah, bonded at that point. It's a plastic box, but it's still going through there and going over to a metal box and bonding that box. So again, guys, hit me up in the comments. I'm trying to do a few more videos here. I'm trying to get on this. If you guys, again, follow this channel, we not only have 12 e-commerce businesses, we just opened up 2 more that we're working on. Facebook's Marketplace. And it's really a great platform. We're loving it. We did start we've had, if you guys follow us on Facebook, we've had our business profile for well over a year now. It hit 5,000 friends and followers, so that's the max. We can't go any higher. We have just started a business profile. I'll include a link down on the bottom, and we cover a lot of things in there. My next video I'm going to be working on is on our Facebook. I actually started doing write-ups, okay, I'm going to explain to people, you know, different things. And I covered load calculations on the last one, which you guys have seen a quick video I did before. A while back, probably about 10 or 15, maybe even 20 videos ago, I did load calculations for solar. But like I said, I'm going to do my next video on that, picking up where I left off on Facebook. On Facebook, I did it as a write-up for people to read. For the very first one, I just don't have time for that. If I want to get on making more of these videos here and you know, running our e-commerce businesses and stuff like that, so I'm just not going to have time to go on Facebook and do write-ups. So I decided I'm going to do videos. So the next video I'm going to pick up on load calculations, you know, explaining to you what's a 500 watt, what's a 1,000 watt power station, how do I know how much I'm going to need to run off of that, and everything like that. So keep an eye out for that, guys. If you haven't checked out our stores, I'll include some links on the bottom. Check them out. We, again, like I said, we had 12 stores up and running. We just decided to open up 2 more in Facebook's marketplace, which we're so far really happy with that. So like I said, guys, check it out. If you like what we're doing here, like, subscribe, hit the notification button, share these videos. If you guys like this, we've been doing this for a while now, and we're getting very, very close to the point where we get into a next level. I'm not sure 100%, but I know right now we don't have highlighted links. You guys have to paste and copy and paste the links in the browser, and it does take you right to where you're going. Also, I read something about us being able to attach our stores to our YouTube video as well. So you guys want to help us out. Like I said, we're about 80 subscribers short of that right now. Our watch hours are basically there. Everything else we've met the criteria. We're just a little bit short on subscribers. So you guys want to help us out, like I said, share our videos. If you haven't subscribed, subscribe. Otherwise, guys, have a great day. I'll see you on the next one.